Hi, this is my 8th experiment in Unix and Linux Lab, which is on process creation. So this is my first question: to create a process and a sub-process, the child of the process. So process A gets the second as an input from the user, and B calculates the hours, minutes and seconds and print it in this format, and finally printing all the process and process ID for A and B. So this is my code for C language. So I have taken seconds, minute and hours as my integer value, and this part is for parent process ID. So this I'll be getting it through get PID function, and I'll be getting the seconds from the user system, and here this part I'll be creating a process using the fork system call, and that process will return a PID, and that PID I'm storing it in this in PID value. So now parent process has get PID, and now process B. So process B is created with this. So if my PID is equal to 0, I have my process ID as get PID, and if you want to display its parent process ID, you can just simply call get PPID. PPID stands for parent process ID. So now for calculating hours, minutes and seconds, this calculations is done, and now finally printing in this format. And I have also used a sleep function also for 2 milliseconds. So enter the seconds. So if I enter my seconds as 60, as you can see here, my printing as as 1 and seconds as 0. So if I again execute, and this time if I execute with my seconds as some 3600 seconds, it will print my hours as 1. So as you can see, after terminating you can see the delay. So that delay is done using the sleep system call. Now moving into the second program. This is my second program. So it is used to print process A read the string as input in a character, and B reverses the string and displays, and C check the string for palindrome, and finally printing all the process ID and parent process ID each for process A, B and C. So B and C are child process of parent process A. So I've included unistd.h header file for this purpose, and str and str1 are my two array of characters, and I've initialized I and j for 0 for looping, and this is my parent process A, and I'll be getting its process ID using the get PID function, and I have to enter my string from the user, that is str set from the question, and I'll be calculating the string length for calculating the reverse of the string, and for palindrome. So string length I'll be printing it over here, and then I'll be creating my fork system call, invoking my fork system call. So through this fork system call, my process will be created, and that will return a process ID called PID, and if my PID is equal to 0, so it will go to this part. So it will calculate the child process IDs get PID. So it is invoked through get PID function. So the child's process ID is printed over here, and then I have my process ID. So this can be done using get PPID as explained previously. Get PPID stands for get the parent process ID. Like this PID will be printed over here, and then this for loop is used to print the reverse of my string. So since I have already calculated the L, so my I will be initialized to L, and I should be greater than equal to L. So it will iterate to that, and then my string, the previous string, will be stored in string 1. So string 1 will have the reverse of the previous one. So finally I will be printing my reverse string in str1. So if it is else part, then I'll create another process, since I have two child process like B and C. So I have to create another child process deriving from A. So C check the string for palindrome. So in that case I have another process and again I have PID is equal to 1. If my PID is equal to 1, again I print my child process ID like get PID, and for parent process ID get PPID. So this get PPID will be same as for B also, since A has the get PID of that number, since get PPID is for that parent process ID. So now this loop is for calculating this is for reversed one, and if the reversed one is matches with the previous one, like it is just simpler an extension of my reverse one, the palindrome. If it matches with the previous string, then it is palindrome, and if it doesn't, it says it is not palindrome. So palindrome words like Malayalam, so it is a palindrome, or like for integers say 1 to 1. So those are the examples for that. So in this case I have to consider strings I will be using with Malayalam. My main I had to return int, so I'll change from void to int, and now I'm compiling it. Since it is .c, so I prefer with void only, and I compile it with cc. Sorry for the inconvenience. So I now compile it with cc. So it's compiled, and now let's have a look on our output. So parent process ID is created with 15561 process ID. So if I enter my string as hello, as you can see the string length is 5. So this string length is used to calculate the reverse of it, like you can see OLLEH, and with this OLLEH I'm calculating it my palindrome. I'll be checking since it is not palindrome. Now let's have a look which is a palindrome. So my string can be Malayalam. Now you can see the reverse of the string is also the same, since the reverse of the string is same as my previous string str, and this is my str1. So in that case I will claim that it is a palindrome. And now moving to the third one. This is my third program in Unix. It is also similar to the previous one, just the extension that we have some more child. Since you can see here, A is the parent process, B, C are the sub process of A, and similarly D is the child process for B, and E and F has its parent process as C. So while I am printing, I have my parent process as, so for B and C my parent process will be A. For D, my parent process will be B, and for E and F, the parent process will be C. So I will be printing all for E and F, the parent process IDs will be C. So A reads an integer as an input, B finds the factorial of the number, C checks the Armstrong, D prints the Fibonacci series, E checks the number for prime, and F reverses the number. And finally printing all the process ID and parent process ID of each of the processes. This is my code in C program. So in this case I have used c/stats.h. So this is my parent process A with ID. I'll be getting it using get ID function, and I have to enter my integer from the user, and I'm invoking the fork system call and it returns a process ID. That process ID I'll be used for creating the answer process B, Z, and all those processes. So if process ID is 0, I'll be creating with process B, and I'll be printing my parent process ID as get PPID, and then child process get as from get PID system function call. So this for loop is used to calculate the factorial of the number using f is equal to f into I, and factorial of the number is printed over here. And again, since I've used another fork system call, since now you can see here C checks for Armstrong or not C for D, since D is a child process of B, so D prints the Fibonacci series, so it is going like this. So D is a sub process of B, so it comes under this for if statements only. So using this invoking of the system call, it returns a PID 1. So with this PID 0, I'll be creating a process D, and I'm printing my parent ID as get PPID. So this get PPID will be of B's PPID, B's get PID, and now I'll be having a child ID as get PID, and then I'll be printing my Fibonacci series using these statements. And then for else part, that is for C, D, and all those parts. For this part C, E, and F, I have this statement, the else statement. So this time I have invoked another fork system call and returning with PID as 2, and if this PID is 0, again I am creating a new process with parent ID as get PPID function call, and with child ID invoking another get PID function call. So I have a while loop. So this while loop is used to calculate the Armstrong of the number, this whole statements including the if statement also. So this whole process is to calculate the Armstrong number, and again I have my get PID 3, so it invokes another form system call returning another PID. So process E is created, and then I have my parent ID as get PPID. So this get PPID prints the CS1 and child ID as get PID. And another I have for prime number, to checking whether it is a prime number or not. And at last we have our final cases for another invoking final one to calculate the reverse of it. So this time also I'll be invoking my fork system call, creating a process, storing it in PID 5 for its process ID, and checking it with 0. If it matches with 0, I say my process F is created, and displaying my process parent ID and child ID using get PPID and get PID function call. And this statement is used to calculate the reverse of my string, and I've used the functions for all the cases over here. Let's have a look on our output. So initializing the parent process A with ID. So 15621 is the PID of my process A, and so I have to enter an integer. So I say 6, and you can see process B is created. Since process B is created, C is also created. So now you can see some delay, so that delay is calculated using a slave system call. So B has a parent ID of 15621 and child ID has 15622. So this PID is of the process A's, and this is its child ID, like B's process ID. So factorial, it calculates the factorial, it is 720, and D is created. Now you can see D's parent ID is 15622, that is of B's, and its child ID is, that is it, the process B's process ID is 15623. So this process calculates the Fibonacci series in this order. And now I have C is a sub process of process A, so its parent ID is 15621, which is the same as of this one, and its child ID is 15624, that is its own process ID. So it says 6 is not an Armstrong number. So process F is created, so its parent ID is 15624, that is C's one, and the reverse of 6 is 6. And finally my process E is created with parent ID 15624, and that is of C's, and my child ID as 15626. So it says 6 is not a prime number. So this was my 8th experiment on process creation. Thank you for watching my video.